Okay, hey everyone, we are back with another programming challenge. It says here, this question was asked by Riot Games. Design and implement a hit counter class that keeps track of requests or hits. It should support the following operations. Record timestamp, records a hit that happened at timestamp. Total returns the total number of hits recorded. Range lower upper returns the number of hits that occurred between timestamps lower and upper inclusive, and we'll get to the follow-up later. I don't know the right way to solve this round. Like the first idea I had, I'm dismissing now. So the first thing I was thinking, let me make some room here to like start doing some pseudo notes. Actually, maybe let me decrease the font size a bit. The thing is, I worked on the prompt similar to this in the past, and what we did was called pyramiding. So we have a stream of events, right? Like here's an event, and then there's another event here, and then there's some events here, something like that. Like, right, where time is moving from left to right. So here's like maybe January, February, March, and so on, and you know, sometimes you have lots of events, and sometimes it's more sparse. And then the idea was you would group these into days. So maybe you say, like, you know, one of them happened on this day, another one happened, 3 of them happened on this day, and so on. Maybe there's 2 here, and then you might group the days into months. Then, you know, so maybe you're saying, you know, 10 of them happened this month, and then 18 happened during this month, and then you can group them to years. And it's called pyramiding because you have like small blocks that like stack up and up and up, the sort of form a pyramid shape, I guess. Like you have 365 blocks at the bottom, I guess, 12 here, 1 up here, or whatever. Anyway, that, like, because this is something I had worked on in the past for a similar problem, this is where my mind immediately went. But I think this is like way too complicated for what's being asked here. My second idea after seeing this is like, well, what if we do some sort of database thing with indexing, right? Where if I have like two indices, one is the hit number, so we have like an auto incrementing hit number, and the other is a timestamp. Then I can, given 2 timestamps, like these 2 guys, I can look at what the timestamp number is for the lower and what the timestamp number is for the upper, and then subtract them to figure out how many hits there are in between. But like even simpler than that, I realize if you just have a list of timestamps, a sorted list of timestamps, then the index of that list is the hit number, right? So like, let's say I'm gonna use like small numbers for timestamps. I can say like at t equals 1 something happened, like the hit happened, and t equals 4 or 5, I guess. I typo, will go with 5, and then at t equals 9, another one happens, and at t equals 11, another one happens. If these are the 4 events, then I have a list where implicitly there's an implicit index in my list, right? So at index 0, we say that an event happened at t equals 1, and at the next index we say an event happened at t equals 5, and at the next index, and so on. And then if someone says, well, tell me what happened between 4 and 7, I guess we would do a binary search to realize, okay, we're interested in what happened between I can't draw in between lines right here, but here's 4 and here's 7, and like, you know, I'm gonna be fuzzy on the off by 1 errors here, and we'll figure that out in a moment. But basically, we're gonna take one of these indices maybe this guy, and one of these indices, like maybe this guy, and then subtract them. So 1 minus 0 equals 1, so there's one event in between. So let me pick a different numbers to make it a little more interesting. Let's say 4 and 10. Actually, let me do, what should I do? Let me do 6 and 15, just so I'm not always subtracting 0 to make it a little bit more interesting. So I take, I guess, this index and the 3 minus 1 equals 2. So I'm saying there's 2 events, there's 2 hits is what this will return, something like that. So we'll figure out the off by 1 error. So like I'm saying I want this index, but maybe I actually want this index. I don't know yet. We'll figure that out. But that's the basic design that I think I'm gonna go for. Okay, so here's the wheel. Let me zoom in a little bit so the wheel's a little bit bigger. Our trusty language selection wheel. Let's spin it and hope we don't get trolled too hard. How do I spin it? Spin, play. Oh, there we go. Scala. Oh man, I haven't done Scala in a very, very long time. Okay, so I don't think I have an IDE set up for Scala right now. So let me set that up. Which unfortunately means I'm probably gonna have to do some video editing here, where we're gonna speed through. I'm gonna fast forward the video here to the point where I got the Scala IDE set up. So, does IntelliJ even support Scala? Hopefully it does. Yeah, it looks like it does. Okay, so let's get IntelliJ downloaded. I'm on a new computer. I'm on a new computer, so I don't have the IDE set up here. Okay, cool. So we have Hello World working, and we can now start on implementing the actual problem. So let me just copy and paste this over. Sorry, I mute the mic because I was about to sneeze. Okay, so once these operations, okay, sorry, excuse me, I muted for a moment there also because I want to blow my nose. But so here's our basic API, right? That matches what they requested. Can we create tests in Scala? How easy is that, or how difficult is that, or what's the expected way to do this? Let's not bother with the official testing. Let's just write our manual tests here. Empty hit counter towards empty. Actually, I guess this is a Javaism. I'm not used to doing Scala. I guess if we're working with an object, we don't need. Well, I guess we don't want to work with an object. I guess we want to work with a class so that we can instantiate this. Oh, Scala uses a new keyword? I thought it was like Kotlin where you don't use a new keyword. I gotta look up how to do generics in Scala, as it's shown here. Method. Here, okay. We're doing some TDD here. Yep, okay, so what happened here is, so we're running our test case. Our test case instantiates hit counter and then invokes Todo. Todo has no implementation here. This is basically a to-do. And so it throws the non-implemented error. So that's correct. So far we're off to a good start. So like I said, the design we're going to go for is a sorted list where we're going to look up the, we're going to do a binary search on the index. So, is there a sorted list type in? I know there's tree set in the JDK. Let me look up what the API is for tree set. Like specifically, can I get the index of something? It doesn't look like it directly gives me that. Okay, so I might have to do my own implementation here. But so we're gonna have a I might have to implement my own sort list that gives me exactly the operations I want. But Todo is just going to return the size of that list. Oops. Now just always return 0, and we'll come back to this in a moment. So this should make the test pass now, hopefully. Yep, let me just do a print here at the end so that we to confirm that it ran. Okay. So now if we insert an element, counter with one element. Reports. Total reports 1. So let's see. Set this to be 1. So this should fail. Oh, I forgot to invoke it. Forgot to invoke it. This is probably why I should, in real life, I would use a testing framework. But I don't want to figure that out right now for the stream. How to set that up in this IDE. I mean, maybe I should spend a little bit more time. Is there, like, if there was a thing here that just said like create Scala tests, I would use it. But if I have to like do the Scala class and figure out what annotations or whatever to figure out, that's a thing I don't want to get into. Okay, so if we record, this is basically on our list. We're saying insert this timestamp. Oh, I might want to say this has to be something that's comparable. So Scala generic bounds. How do I say that I can do any t, but it has to be a comparable t? Like that, okay. I guess internally we're just going to use an array list. And then, so we'll implement the insert operator here. And this is going to be now just internal dot size. For this guy, let's see. So we're probably going to want insertion point. And this isn't necessarily an instant, it's just whatever t is. So what this is going to do is it's going to return the index at which we would insert the provided element. So this doesn't actually insert it, but it finds the index where you would insert it. And the reason, we're going to reuse that in a moment, but it's also going to be used here by this guy. I'm going to take a sip of my drink here. Okay, so base case is if size 0, then just return 0. Otherwise, we'll pick a midpoint or something like that. Size of 2. Value at midpoint equals return midpoint. So not the syntax, is it get or something? Get midpoint. I'm more used to Kotlin, so you might see me use like Kotlin style syntax accidentally here and there. Oh, so we probably want to do this recursive algorithm here. So rather than saying size equals 0, what we would say is if lower bound is greater or equal to upper. Well, let's do some error condition checking. If lower bound is greater than upper bound, go new. Then otherwise, if lower bound equals upper bound, return either of them. Otherwise, the midpoint is how do I figure out the midpoint? It's gonna be like lower bound plus lower bound plus upper bound minus lower bound divided by 2. Right? I think. Let me just do some sanity checking where I say lower bound is 0 and upper bound is 1. 0, 1 divided by 2 probably gets around to 0, so 0. So we say the midpoint is 0. Or what? Lower bound is 0, upper bound is 2. 2 minus 0 is 2, divided by 2 is 1, so 0 plus 1 is 1. Okay, that seems okay. So we get the value at the midpoint. We say if it's less than value at midpoint, if it doesn't like this, so I have to actually resolve this. Okay. I can never remember less than 0. I think less than 0 means this guy is smaller than this guy. So if this guy is smaller than this guy, then I want to set the midpoint as a new upper bound. So same lower bound, but the new upper bound is the midpoint. Otherwise, in this case, this guy is bigger than this guy. So set the midpoint to lower bound. Same upper bound. But I think maybe I might need to do +1 here because I think because of this I'm rounding to like. So consider the case where lower bound is 0 and upper bound is 1. This calculates midpoint to be 0, but we know it's bigger than 0. So we don't want to look at 0 again. We want to look at 1. In the other guy's case, we looked at 0 and we know it's smaller than 0. So I guess we can do this also. Is that safe to do? I don't know. We'll check it out with tests. Otherwise, if they're equal, if element that we're trying to insert is equal to the value at the midpoint, we can just say, well, let's just say it is, let's just return the midpoint. Return keywords redundant. Well, that's fine. Okay, so we'll have to check if this if there's any bugs in this thing. We'll check that later, but for now, assuming there's no bugs, let's say point equals this guy, element 0 to size. Might do size -1. I think I'm treating this as if it's inclusive. No, I think there is a bug here, because I'm thinking if lower bound is 0 and midpoint is 0, then I'm going to do 0 to minus -1, and that's going to cause a problem here. So I think I want this to be like this, 0 to 0. And then, so this is, can I rename this? This is going to be inclusive, and this is going to be inclusive. So if the upper bound is exclusive, then this is fine because we know the midpoint. We know it's smaller, strictly smaller than midpoint, so we want to exclude that midpoint. Here we know it's strictly bigger than midpoint, so we want to exclude the midpoint, but currently it's included here, so we want to do the +1 here. And if they're equal, then we say we can insert at the midpoint, so that's fine. Let me think about that. So if you have a single element at, no, let me actually write out these test cases, I guess. I'll rename these guys to test hit counter. Now create test sorted list. Inserting into empty list. I don't need this unit equals, I can just do this. Well, I want to put the unit equals, okay, whatever. So give me insert list of int. Just insert 1, whatever, and then assert equal, the expectation should be 1, and the actual is that. This is pass. I'm assuming it doesn't pass right now. Doesn't even compile. What? Int is not comparable? Are you kidding me? Int is indeed not comparable in Scala, certainly because it is in fact as Java int, not Java int. I'm sure that would have been possible. What you usually do is say that there's an ordering available in implicit scope with ID ordering. This amounts to passing and ordering function. Alright, so basically we use ordering instead of comparable. is what this guy's saying. Ordering or ordered? Ordering, I guess. Well, what methods do exist on ordering? Okay, like this, I guess. No? How the heck do you use this? You do use this thing, okay. Counter's house symbol, wow. Why not? Okay, I don't want to figure this out right now, so I'm just gonna remove the generics. I'm gonna say this has to be a list of long, and then we can come back and figure out the generics later. Yeah, so this is if element is smaller than value at midpoint. If element is bigger than value at midpoint. Is this not right? What is this? Oh. Okay, whatever. All right. So now, is this an error? I don't know. It's in red, so I don't know if that means an error. Oh, it is an error because this is no longer generic. Okay. So let's take a let's see the test passes now. Sure, let's just not take type primary. Here we go. Get rid of this. Lower bound is greater than upper bound. Okay, so there is a bug here somewhere. I don't want. I guess I changed this. Maybe I wrote that when upper bound was inclusive, but now I want it to no longer be inclusive. So I don't want the -1 here. I'll test pass. Let's insert 1 then 2. And then I'm gonna do a getter, I guess, for testing purposes. Get this int, and then the result is a long, and I'm just gonna return get index. Just don't need these brackets probably. Other test. Expect this to be 1. Let me make this a different number just so it's a bit clearer. Okay, so otherwise if I insert like 5 and 6, then I expect the size here to be 2. Elements. And then I expect this to be 5, and this to be 6. And if I 2 elements rock in order, if I do 6 and 5, I still expect it to end up in this order because it has to be sorted. All right, I put a bunch of tests, but I didn't actually invoke them. What's the syntax for lambdas? How to invoke a lambda? I just put parentheses after them. Okay. So can I do something like JavaScript's trick of immediately invoke lambdas, right? Let's try this and see what happens. Because then I won't have to remember to invoke them afterwards. If I get this syntax to work. Just to make sure it's actually running, let's put a failure on purpose. Yep. It's actually running. Okay, cool. All tests pass, really? Wow. I'm skeptical. Let me change this to this and see. I want to see the failure because to make sure this actually, wow, it really does. It really was running. Okay. So there's our sort of list implementation. There might still be bugs in it, but hopefully we'll notice them and we'll fix them with some more TDD. But okay, so for now, we have record, total, range. So that's our sort list implementation. Test hit counter. Empty hit counter reports empty. Hit counter with 1 element. Total reports 1. Here 1 element. Range overlaps. Reports 1. Let's do that test case. So now instead of doing instead of just saying like any arbitrary timestamp, we're going to pick some actual timestamp. So here we're going to say I'm going to insert a timestamp at t equals 5, and then I'm going to say now tell me what's in the range of 4 and 6. And this should be 1. Let's check that. I mean, it's not going to work because I have a to do here, like so. But we want to see the test file. Okay, cool. So now here's the real. We're getting into the meat of the problem, right? So here's where I would want to know. I guess what operation do I want? I gotta think about this. So given the lower bound, I want the first index greater or equal to that lower bound. Okay. So I'm gonna do something like x of first greater or equal to, and then so what does this mean? This means if we have our elements, right? I'll call them numbers 1, 2, 3, 4, 5. No, I'll call them letters. So because I'm gonna make the index of these be numbers, and needs to give me like index. If you pass in C here, I'm gonna say okay, this is 0, 1, 2. So I'm gonna return 2. I'm gonna return you the index, the smallest, the first index, so the leftmost index in this diagram, such that the element there is at least as big as what you pass in. So if you pass in C, it's going to say C here, and if this wasn't here and you pass in C, well then we would return the index of D, which is 0, 1, 2, which is 2 in this case. So let's write some tests for that. Test sort list dot, what did I call it? Get index of first greater than or equal to for C from A, B, C, D, E yields 0, 1, 2. That's the test case. So I'm gonna insert it says like 65 in ASCII or something like that. 9, and then I'm gonna expect 2 for get first index equal to, and let's change these to numbers. So this is 65, 66, 67, 68, oops, 68, 69, and if I ask for 67, I expect 2. Then we're gonna have another test case where this is missing, but I still expect 2, right? 0, 1, 2. We expect the index of 68 here. Okay, let's check if these tests pass. I assume they don't because I think I put a to do, right? I didn't actually put an implementation. Yeah. Come on, I want to see the failure. Yep, okay. So the question is this just equal to finding the insertion point? I don't know if it is or not. So I guess we'll find out. Let's just make the test pass. What's not implemented? Oh, I didn't actually implement range. Okay, but I guess that means that first test pass. Where am I invoking this one? There's gotta be some lambda somewhere. Here. Yeah, okay. Equals, let's go get index of the first element greater or equal to the lower bound. Am I doing epoch seconds everywhere? Yeah, okay. It'd be nice if I could figure out the generic thing. Maybe we'll do that in a later pass, so I wouldn't have to keep doing this transform each time, but whatever for now. So similarly, for the upper index, I'm going to say I want, what's the idea here? The idea here is, we'll use the same example, right? Or we'll use a test example even. Four, five, six, okay. So if I'm looking for the guys between 4 and 5, I'm going to say, well, 4 is here and 6 is here. So the index of the smallest number greater than 4 is going to be 0. So this points me to 0. And then I want the index of the biggest element no greater than 6. So getting the index of last element smaller or equal to my upper bound, it's also going to give 6. So then I can probably do something like upper index minus lower index plus 1. Right? Why? Oh, maybe because it's a weird error message because this can't resolve symbol. It's really more that it doesn't know what this method is. But whatever. I guess this is because in Scala you can do operator overloading. Or maybe the more precise way to put it is in Scala operators are just methods with funny names. Okay, so how do I get the last index smaller or equal to? I think I want something similar to this, but I want to like bias towards overestimating rather than underestimating, right? I'll just do some copy and paste at first, and then we can refactor it as we find commonalities. So I call this bias towards smaller. Nope, it didn't do the refactoring. And then what if I have the same method but bias towards bigger? What would that mean? I think is the only place where that matters here. No, this has to stay the same because if the upper bound is exclusive, so like let's take the case again of a list of size 1. So there's one element in there. Lower bound is going to be 0, upper bound is 1. So I still want to compare it with that midpoint. If I know it's okay, I think the only change is here. So if I know it's strictly smaller than that midpoint, I do need to look to the left. If I know it's strictly bigger, I do need to look to the right. But if they're equal, then I want to look towards the right because there may be other guys who are also equal. Does that make sense? Let's try that. Let's see if this works or not. Where's my test runner here? Expected 1 but was 2. Okay, why was it 2? It's saying that this returned 2. Okay, maybe no. Then maybe I don't need. Maybe these are all the same. And I don't need the other guy. Let me think about that. Even with this change, it's still 2. That's weird. How do I run the debugger on this thing? Here. Upper index is 1. Oh, yeah. Okay, so this is asking where would I insert 6? And the answer is I would actually insert 6 here. But that's not okay. So, but that's not the question I want to answer. The question I want to answer is, what's the smallest element to get the index of the last smaller or equal to element? Which I guess, okay, so this is, I do want bias towards bigger. But then I want to subtract 1 from here because I don't actually want to insert it. I just want to find that smaller element. Okay. Alright, so what about the test case where test hit counter dot range 1 element range does not overlap. So here, say if I only have an event at 7 and I want tell me what happened between 4 and 6, I'm going to say there are 0 events in that range. Let's test. I'll test pass. Okay. What about range? It has some elements. Range overlaps with some of them. So we're gonna stick with 4, 5, 6. I'm gonna go let's do 3, do 5, do 6, or do 8. So 5 and 6 should be included, so I should say 2 here, right? That passes. Are we done? Does that implement all the use cases? I can do a whole bunch of boundary checking. So what about if we also have a 4 here? So now it's 4, 5, and 6 are all included, so it should say 3. Nope, something didn't work. Okay. I don't know what this delayed endpoint stuff is, but... Three, but was 4. Okay, so let's debug this case. Oops, I don't want to copy class, I want to step in. What's the shortcut for stepping in? Step into F7. Alright, so 4 and 6. This looks like 3, 4, 5, 6, 8. So what do we expect for lower index? We expect 1, right? Is that what we get? So we're a step over. Lower index is 1, so that's good. First, upper bound is 6, so we would want 3 as the answer. Oh, this might be where that biasing thing happens because of equality. So we might have to be careful with this one. Okay, so let's do an explicit test for that. Here, I'll do it this way. Is this one? No. This. 1. 0, 1, 2, so I should say 2. And what about if that guy's missing? 0, 1, I should say 1 for this case. Alright, let's check that. Which one failed? Wait, those two guys passed, but then... Are you kidding me? I can disable this test for a bit, because I don't understand. All tests, what the heck? So these these methods are correct, I guess. Let me just double check the asserts here. Index of first greater or equal to, no, but where's last? Oh, that's a problem. I didn't call the right method. Last, so I want to find this guy. Wait, I'm so confused now. Undo, undo. And what did I... Who am I changing here? Get index of last smaller or equal to 67 from this. Except I do have a 67 here. Let me read through my tests again. I think I'm mixing up two different test cases. First greater or equal to 67. First greater equal to 67. I think I just pasted in the wrong place or something. I got the order in a weird order. I want the last guys to be after the, like the methods testing the last, get last to be after these guys. Okay, so here's first with 67 present. Here's first with 67 absent. Now here's last and last, 67 present. And then I want a case where 67 is absent. That's what I was missing. That's the test case that I got confused about. With this guy still? Okay. I'm surprised this guy still passes. 0, 1, 0, 1, 2. 0. Oh, maybe this is wrong. First, no, this is right. It's asking for 68. Okay. Huh. I'm still skeptical. Did I really? Does this really work with the existing code? Let's say 6. What's the last element smaller or equal to 67? It is 66. Okay. Apparently that works. Then the bug isn't where I thought it was. So let's run the debug run and check again. Step into, step over. So let's check if lower index and upper index are correct. So we said the lower bound is 4. The list. Show me the list. 4, so lower bound should be 1. Yeah, that looks correct. Upper bound is 6, so it should have returned 3, but it returns 2 instead. That's weird. Why isn't the test catching that case? Get last index smaller. So isn't this analogous to the other one there? If you ask for, well, let me just create a test case that exactly mimics this one. Asking for 6 from 3, 4, 5, 6, 8. 3, 4, 5, 6, 8. And then you ask for 6. You should get 0, 1, 2, 3. Okay, this one fell, so that's good. It would have been super scary if this had actually passed, because then I'd be like, what the heck is going on? So let's debug this guy now. Step into. So we're looking for 6 from this. So. And okay, so lower bound is 0. Size is we don't know, but we'll probably know once we step in. Lower bound is 0, upper bound is 5, right? And what's the list? Okay, that looks fine. What's step over again? Is it F8? F8, so I'll be hitting F8. So the midpoint between 0 and 5 is like 2-ish, I guess. Midpoint is 2, yep. The value at 2 should be 5. Yep. So then we say, is 5, is the element we're looking for smaller? No, it's not. Is it bigger? Yes, it is. So now we're gonna look at in here. Midpoint is 2, so we're gonna look between 3 and 5, I guess. I think I hit the wrong. I think I hit step over instead of step into. Welp. Let's try that again. And try to hit the right key this time. Step into, step into, step over, step into, over, 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 step into. So yeah, now we're looking between 3 and 5. Between this and off the edge of the list. So the midpoint between 3 and 5 is probably 4, maybe? Midpoint is 4, yep. So value at midpoint is 8. Is it smaller than is 6? Yes, it is. So we're going to look between 3 and 4, I guess. Step into. So 3 and 4, yep, that looks good. What's between 3 and 4? It's... Oh wait, why am I calling bisort smaller? I want to call bisorts bigger, right? If I want the last one? Oh! Okay. The bug is that in bisorts bigger, I did recursive call to bisorts smaller instead of bisorts bigger. That's the problem. Okay. Mystery solved. So now if I just run this whole thing, all tests pass. Phew. Do I need any other test cases? So I have a test case with 4 and 6 where both the upper and lower bound overlap. I have here where the not just overlap, but the inclusiveness matters or is in effect. Here 6 is inclusive, 4 is not. 4 is not present. Got this. I guess we can do a test where here 4 is absent, but here we're gonna make 6 absent. We already have a test where both are absent, so let's do one where 4 is present and 6 is absent. So just 4, 5, 3, 4, 5. So that should be 2, right? Rerun the test. Yeah. So I think that solves the basic problem. We can try to figure out the generic thing. So the other thing we could try to figure out is there's a lot of duplicate code between these two. Can we do something to improve it? We could add in a parameter that says which way you want to bias towards. I'm gonna mute because I'm gonna cough for a moment. Okay, sorry about that. Are there enums in Scala? Object sense enumeration. Bias direction. Smaller, bigger. Doesn't like this? Why not? I do have to import it. Yeah, I have to import it. Okay, fine. Can I do a switch statement or case statement? Like this. Show me how to do a freaking case statement. Oh, match. Okay. It got larger or it got bigger? Just rename it larger. Larger. Is that good? Is there still compiler somewhere? Smaller for this guy. It doesn't matter actually. We can insert at the smaller place or the bigger place. It's for this one. It doesn't matter which way we insert it. In fact, let's insert in a larger place. Okay, so now I'm going to rename this. So that should all still pass. Do we want to figure out the generics, or I think if this were a real interview, I don't know. if this were in real life, I would definitely want to figure out the generics. Like I wouldn't want to commit code where this is hard coded to be long. In an interview thing, it's an open, like I'm not sure if I want to focus on that or if I want to focus on the follow-up, because we haven't done the follow-up yet. What if our system has limited memory? So I think for the purposes of this video, I'm going to focus on this. I'm not going to worry about generics. Generics is something we can, like, you know, you can just Google and you can read an article or something like that, and you'll probably find lots of tutorials on generics, and we'll just figure out the syntax. It's not a big conceptual problem. It's just a syntactical problem. But this might have some interesting discussion in it, so let's focus on this part. What if our system had limited memory? I don't think there's a one right answer for this. I think this is intended to be an open-ended question, because it's severely underspecified, right? Like, what do you mean limited memory? Like, you mean we only have 1 byte, you know? Like, in which case you can't even store the timestamp itself. You're basically screwed at that point, right? But so like it makes a big difference what precisely is meant by limited memory. Because this isn't an actual interview, I can't ask the interviewer what they mean by this, so I'm just going to make some guesses at the interpretation, like some possible interpretations. What I'm thinking is they want to, first of all, I guess they would want to do like, what's the big O analysis for memory consumption, maybe even runtime consumption. So let's do that first. So we have 3 operations. The rest is all this stuff is implementation details, but what we really care about are what's the I guess runtime and memory consumption of these operations. So recorded timestamp runtime it's basically O1, I believe. I'm using ArrayList, which I think does what's the word? I can't remember the name of the term, but there's like it's O1 on average over time, because what I believe ArrayList does is it allocates an array of some size, like say 16, and then when you insert the first element, that's instantaneous. You're just writing into the first array slot. Then when you insert the second element, that's also instantaneous, and then this is true until you get to the end of the array, in which case it copies over. It creates a new array of size like 32, basically double, and then copies over the 16. So that part so inserting the last guy takes on time, right? Because it has to copy each element of the array, but that only happens like 1 out of every n times. So it's quote unquote rare. Like it takes order n time, but it only happens 1 out of n times. So it, like on average, it happened n divided by n is 1. So it's O1. No matter what, that's inserting at the end of the array, which I don't know exactly what they intend here. Do they intend to record timestamps out of order? If they're just recording a hit, like I would, the more ideal API I think is you don't pass in the timestamp. You just invoke a 0 argument like record hit method, right? And then this system does the auto incrementing timestamp basically. But if they want to insert timestamps out of order, that means you might be sometimes inserting into the mid of the array, which for array lists is could be more problematic because you have to then shift all the elements in the array over, like to copy them over basically, right? In terms of like big O analysis, the easy fix for that is just to switch over to linked lists, right? Like, so this implementation has the same contract as ArrayList, so meaning the test should all still pass like exactly the same, even if we switch to that implementation. Good, it did. I'd be pretty embarrassed if it didn't, because I'd have to figure out an explanation for why not. But anyway, oh, but I don't know. This might be the Scala linked list rather than the Java linked list. I don't know. This should still pass, I assume. Yeah, okay. Because I know Scala has its own collections implementation, which I don't know the performance characteristics of it. Like, in real life, I would just use whichever was more convenient, either the Java implementation or Scala implementation. But if you're asking me like we need big O bounds, then I would either have to use the Java ones because I know they're big O bounds, or I would have to like go online and research what the Scala big O bounds are, depending on the context of why this question is being asked. But anyway, if we just switch the linked list, then we can insert in the middle in what? Oh, end time? Dang, no, because you have to iterate, right? Like adding to the. Do we have a way of jumping to the end of the list? I don't know. I don't want to spend too much time on this. Like I feel like there are other data structures we could look at, like maybe a heap or something like that. I really want to use the sorted maybe a red black tree or something like that, but I don't want to actually implement it myself. That seems like a pain. But I'm pretty sure there are algorithms that let you or not algorithms, data structures that let you insert into arbitrary points in O log n time, basically, right? It's just that wasn't the part of the problem I want to focus. I'm saying that surely there is such a data structure already made for me somewhere. I can just grab that and stick it in. And the more interesting part was this class, right? Of using that data structure to make this class work. We could either find an existing implementation online of such a data structure, like a red black tree or whatever, or worst case, we just crack open the textbook, find a reference implementation, and just implement it here. So time for arbitrary login for arbitrary timestamps O1 if O is appending a bigger timestamp. Space. I mean, each time you invoke this, it adds like one constant amount of space, right? Like one timestamp. Basically, we're storing one new timestamp. Total, I believe this is O1 for time. I believe all reasonable list implementations, and even linked lists. Like I don't think linked list calculates the size by iterating over the linked list. I think it has a private field that it stores internally to keep track of how many elements are, and it just reads from that field. So time is O1. Size, I don't think it's meaningful. Like O0, or is it, this doesn't use any space at all. Well, I guess it uses, if for the linked list, you might need one extra field to store the size. If you're using array lists, the array inherently, so like the size that you were already using for this guy is reused here. This guy, range. So I believe this is time is O log n. In the sense that we have to do a binary search on this, we have to do a binary search on this, and then we do a subtraction. So it's like 2 log n plus 1, like plus a constant, right? The constant is dominated by this factor, and then this is just multiplication by constant, which doesn't matter in the big O measures. So that's the time. For the space complexity, does this use extra space? And my implementation right now does, because we're using recursion, but I think there's telrec or something. I don't know. Oh, it's an annotation. Or is it? Metadata with telrec is neither private nor final, so it can be overridden. So let's make it final, I guess. Is that not how you do final? Let's make it private then. It's not in tel position. What are you talking about? Is it now in tail position? I guess now it is in tail position because everything compiled and ran. Yeah, so the reason I get into tail recursion is because if you use recursion in theory, you're using as memory, like the call stack, you're using as many, you're using a new call stack for each recursive invocation, right? So this could be like, if you're doing login invocations, then you would have used log and memory because you use login call stack frames, right? But now we made tail recursive, which lets it reuse the same stack frame each time. So that maybe, let me check it. Like that might be constant memory. We have an integer here. We have a single element here. Yeah, I think it's a constant memory now. Then. Because it's not like we're creating a data structure. It's not like we create an array as a temporary, for a local variable that is the size of the list or anything like that. So memory pretty efficient all around, right? Like constant memory for each operation. It's linear memory with the number of timestamps you insert, because each time you insert a timestamp where we're using more memory, we need to store that timestamp. So I think, like, to quote unquote properly solve the problem, this is pretty close to optimal. Like it's optimal within the big O class, right? But can we do better? Like, right? What are we willing to sacrifice some things here to squeeze out more memory? And like I think that could be a realistic question, because, like, you know, is this Riot Games, or like, so any big popular website probably gets lots and lots of hits, right? And I don't know what this is for. I guess this is to make pretty graphs for reports or something like that. And there's this idea that the reports are probably gonna come in at some known cadence, like maybe we want a weekly report, or we want a monthly report, or maybe even a yearly report, but we don't want like from this millisecond, you know, in this arbitrary date in May to that millisecond in that or whatever in June, or like those reports would be weird, right? You don't expect those reports to happen. So there's this idea that you could do something like that pyramiding thing I mentioned before, where for our data structure here, we might just store only the most recent, the last 30 days, trailing 30 days, we'll say. And then as hits fall out of that window, we could move it into a more like archival store, right? So the idea is, like, you'd say, like, in January you would have some number of hits, in February we have some number of hits, March, April, May, and so on. And then we get to, where are we? Now we're in August, right? Today is August 3rd, so we would say in July we had whatever number of hits, and August we say it's still in progress. Actually, yeah, even July we would say still in progress, in the sense that if today is August 3rd, then the trailing last 30 days is like July 4th or something like that, right? Because July has 3 1-days, I think. Yeah. So the idea is, we have a sliding window. Our stored list is a sliding window of the last 30 days, where you can, if you invoke the range method with, you could ask for like any timestamp within the last 30 days, and we would give you, like, exactly within those periods, here's what the hits were, right? But if you ask beyond those 30 days, we could only give you approximating using the previous month's data. So June, all the June data is I'm just mashing the keys here, is complete, right? We know in June this is how many timestamps there were, and this will never change, quote unquote. And this is that we would have to add. We have two possibilities. Either we add some validation that says if you try to record a timestamp that's more than 30 days in the past, we reject it. We say no, sorry, we're locking down this data and it's immutable and you can't change it. Or if we say, okay, it's more than 30 days in the past, so we'll just find the bucket. Like maybe you want to record something in February, and we'll just increment this number, but we won't store the exact timestamp. And so you can't query, you can't say like what happened between February 7th and February 8th and expect to get the exact number, because we no longer store that number. We've aggregated the data into this compressed form, and it's a lossy compression. We've lost some information. We have a couple of options in terms of API design for what we could do there. If one option is, if you ask me for a date that's beyond the last 30 days, I just reject it. I say, sorry, I throw an exception or something. I say, well, we can't get the data for you, so we don't know. So sorry, you're out of luck. Another possibility is that if you ask for any period in February, so like if you say like what happened between February 7th and February 8th, I just give you the figure for all of February, right? I say I return this value, and it's a big overestimate, right? Because I don't know how many happened exactly between February 7th and February 8th, but I know that this many happened in February, so I'm just gonna give you that number, which is probably, unless nothing happened on any other days except February 7th, this is gonna contain events that are not what you're looking for, but so you have an upper bound at least. Another thing we could do is we could try to do some sort of like averaging thing, right? We could say, well, this is how many happened in February, and February has like 28 days in it, so we're going to divide this by 28, and then see how many days are in your range, and then we do. If we say, well, it's probably approximately, if you say February 7th to February 8th, that's 1 day. So we're going to say this divided by 28 because there's 28 days in February, and we return like 822. We're going to say, well, it's probably around 822. It was the number of hits, and we're just interpolating, or if you like, what the value probably was approximately. For this guy, we would have to, this becomes, it could either be an ON-ish operation where n, like a different, I'll say OM actually, it's a different variable. It's not the number of times that, but it's like the number of months. We would have to iterate over the months and sum them up. Or we can just keep a trailing count, right? We can just, somewhere else, we can just store the total that we, and each time we do a record, we increment this. I mean, just storing a big number doesn't take that much memory. So we can make this be O1 if we just add a new field to keep track explicitly of the total. So yeah, that's what I think. I think that's the most interesting interpretation of this question. There's the less interesting interpretations where like fewer memory means like you only have 1 byte. What do you do? And it's, well, I can't do anything. And then I'm pretty sure that is the correct answer if you only have 1 byte. I don't think you can properly implement any functionality in only 1 byte here. Yeah. So I hope you found this interesting. Keep sending me programming challenges if you have an interesting one you want me to take a look at, and I hope you guys have an excellent day or evening or wherever you are. Thanks for watching. Catch you guys next time.